All right, let's have story time. Random variables. Random variables. Okay, so in general, a random variable can be thought of as a variable whose value depends on chance. Okay, so for example, now we've got a couple of types of random variables that we'll talk about in this course. Discrete random variables and continuous random variables. Discrete random variables take on values from a finite or countable set. So that from a finite or countable set. Okay, so for example, the number of cars in the parking lot tomorrow. Okay, you can't predict that with certainty. How many cars will be there tomorrow? I don't know, but it'll be some integer number of cars, probably 98, 99, or 2, or even 0, or 1, or 100 million, whatever. But it's going to be some integer number. Okay. Also, the amount of money in your bank account is, you can be thought of, you can think of that as a discrete random variable. You know, the amount of money that's there tomorrow. You know, who knows how much you're going to take out tonight when you go out on the town. So you don't know how much is going to be left. Is it there going to be $0 or a hundredth of a dollar or 2/100ths of a dollar or 3 cents or 4 cents or $1,000 or $1,000 in a penny? Okay, so this is it's really a discrete variable. We think of the lowest possible increment of money is a penny, typically. Your shoe size, the shoe size for a randomly chosen individual, like 9 or 9.5 or 10. You never see 10 1/3, right? Okay. The height of a randomly chosen individual, according to their driver's license, right, can be 5'2", 5'3", 5'8", 5'9", or whatever, right? Okay, so what about continuous random variables? For example, the total weight of all the cars in the parking lot tomorrow. Okay, how much are they going to weigh? I don't know, but we tend to think of the total weight of something as something that takes on a value from a continuum, right? Things like time or weight, or sometimes volume or mass. We tend to think of these things as really taking on values from a continuum, right? Like sort of like a piece of Scotch tape. You can cut it anywhere. You can cut the Scotch tape anywhere. It doesn't just break off in discrete little pieces. The actual foot length for a randomly chosen person can be thought of as a continuous random variable. Their shoe size would be a discrete random variable, but the actual foot length for a person chosen at random would be could be thought of as a continuous random variable. And similarly, the height of a randomly chosen person. Okay, the actual height of someone is chosen at random will be a continuous random variable. Now, let's get a little bit more specific. We won't use the following much in this course, if at all, but I do want to tell you about it because this is the truth. This is the actual truth. You always wonder what the truth is? Well, here it is, folks. I'm giving it to you right here. In general, and more correctly, a real valued random variable is really a function from a probability space, whatever that is. Here's the probability space. That's our notation for it. To the real numbers. What is a probability space? Well, think of it like this, okay? It's real simple. This is omega. Omega is the collection of all the possible things that can occur when we do an experiment. This is a funny looking F. F is for field, I guess. Okay, so all this is the collection of all the events of interest, all the meaningful events in here that are subsets of the sample space. Okay? Like the collection of all these circles, okay, and all their unions and all their intersections are in there too, and all their complements, okay. And finally, P, this is that probability function, okay, or probability measure maybe, okay. So a real valued random variable is a function from a probability space to the reals. Let me give you a picture of that. Okay, so here's our Venn diagram. We love this because this is the place where you perform an experiment. You get an outcome somewhere in there, and right, if you get the outcome in here, then this event has occurred. If the outcome is in here, then this event has not occurred, but both this and this event have occurred, right? We've played with those before. Now I tell you what, I'm going to take this Venn diagram and I'm going to throw it back on its side, okay? So that now, maybe I'll draw it just a little bit bigger, okay? Now, it's kind of like this, okay? Here's our Venn diagram. Let me put those circles in there. Okay. I guess it looks something like this, sort of. It's not very good, is it? It looks something like that. You get the idea? It's just, I've taken the Venn diagram and I've laid it over on its side. Okay? It's omega. Now, what we really have, though, is to talk about random variables, is take a real line and just drop it right down through there. Okay? Put it anywhere. And now maybe I'll do something like this. Why not? Okay. What I'm doing is I'm drawing a function that sits over the top of this probability space. Okay, here's our probability space. That's what we're calling this now. It's not just our event. It's not just our set of outcomes. It's also, we're acknowledging that we have all these events of interest in here and their unions and complements and so forth that make up F. Okay, and then we can also talk about the probabilities of these things. Now, it turns out, though, that a lot of times we aren't just necessarily really interested in what goes on down here in this probability space, but sometimes we're much more interested in a function of what goes on. Like, for example, if you arrive at 5, okay, you could arrive at 5. Where is that event? Right here. That's you arriving at 5, and you wear a green jacket and your dog has worms, okay, or whatever. If all that happens, maybe this function up here, which this function is actually our random variable, okay, then maybe this is the value that you get. You win this prize, this amount of money. This is our real line. Okay? Maybe this is you, or this over here, this is you arriving at 5, but you wear a brown jacket and your dog has worms. Okay? Okay, so maybe that results in that amount of money. Okay? Maybe this is you arriving at 5 and you're wearing a brown jacket and your dog is very healthy, okay? Alright, so in that case, you win that amount of money, okay? There are a lot of things that could happen. You could arrive at 5:05 and, you know what I mean? At the end of the day, you don't care if your dog has worms or what color your jacket is or what time you arrive. Instead, you want to know how much money did you get, right? So that's the idea. Sometimes we don't care what's going on down in here. We want to know about the random behavior of this function of this where our random experiment takes place. Okay? So this function here is called a random variable. This is really the proper way to think about this, okay?